This is for the practice problems for Chapter 6. This is number 2 and number 3. We're doing them together because they piggyback off the same information. And this is good test-taking advice. Sometimes you've already done the work, especially if they say refer to problem number blah. Don't redo your work if you don't need to. All right, so number 2 says tungsten metal is produced using the following reaction. WO3 plus 3H2 yields W plus 3H2O. So I guess the question we're really, not I guess, but the question they're asking is they're saying how many grams of tungsten, so what they're looking for is grams of tungsten. All right, can you make from 1.0 to, oops, that should be a superscript 6, 10 to the 6th, 1 times 10 to the 6th of hydrogen in excess WO3. Now hydrogen here, don't forget, is H2. It's that diatomic hydrogen. So we are given grams of hydrogen and we are trying to get to grams of tungsten. And recall in stoichiometry, if we were to have a roadmap for ourselves, we would start at the grams of the known item, which in this case is hydrogen. We would need to get that into the moles of hydrogen because we can't easily relate those two masses to one another. We have to go through this step, otherwise it just doesn't work out. And then once we know how many moles of hydrogen we have using the chemical reaction, we can get 2 moles of tungsten. And then once we know how many moles of tungsten we've got, we can get 2 grams of tungsten. All right, so let's go ahead and get this party started. First, I know that I am going to need the, and many of you can do this in your head, I'm going to need to get the molecular mass of H2. Just for form, we go to our periodic table. The mass of just one singular hydrogen would be 1.008. So what we'll do is we'll say, okay, I've got for H2, I've got 2 hydrogen atoms, 1.008. And when I multiply that out, that's 2.016. All right, that's atomic mass units, or for 1 mole of H2, that means I have 2.016 grams of H2. Okay? So, knowing this, we can get our quantity, our known quantity of hydrogen into moles. So, what we'll do is we'll say, all right, I've got 1.0 times 10 to the 6th grams of H2. All right, and I am going to say 2.016 grams of H2 is going to go on the bottom. I want those labels to cancel out, if you will. All right, for every 1 mole of H2. All right, when you solve that, you will get you will get 5.0 times 10 to the 5th. Assuming I've been a very good girl and done my math right, moles of H2. All right, so going back to our little roadmap, we started out with grams of H2, converted that to moles of H2. That's where we are now. Now we need to get to moles of tungsten. So what we're going to do in this case, I'm going to just scooch up here, is we know first, I'm going to show you this. We know that because our chemical reaction is balanced, for every 3 moles of hydrogen that you have, you will get 1 mole of tungsten. So I can relate this moles of hydrogen I just got down here to moles of tungsten. I can do that by saying, all right, I've got my 5 moles, 5 times 10 to the 5th, rather, moles of H2. I'm going to do my nice little bracket, helps me keep things nice and clean. All right, if I have, I said, 3 moles of hydrogen, H2, for every 1 mole of tungsten, Essentially, I'm just dividing that number I had right there that I got in my first equation, just dividing it by 3. So at this point, what you will see is that you have 1.7 times 10 to the 5th moles of tungsten. All right, now that we've got this, we are going to look at it and say, all right, I've got, back to my roadmap, I had moles of hydrogen, now I have moles of tungsten. Now I just have to get the grams of tungsten. Well, good news, guys, they went easy on you with this one because we don't have to do a whole molecular mass. Computer, stop. Let's see, I guess I'll stop after this one because I do have to go to church. But we're going to have moles of tungsten, the weight of tungsten would be 183.8 AMU, and it's just tungsten. They're not asking us for any compounds, so there's nothing to add here. So what we would do at this point is we'd say, okay, well, I know I have 1.7 times 10 to the 5th moles of tungsten, and for every 1 mole of tungsten, I know that I have 183.8 grams of tungsten. All right, when I do this math, I will get what? I will get 3.1 times 10 to the 7th grams of tungsten. All right, so we're doing pretty good. Number 2 looks like we got our answer there. All right, the next problem here says how many grams of WO3 would be used in the above reaction under the circumstances. All right, let's go ahead and do our roadmap. We started in the previous one with grams of hydrogen. All right, and then we went and we got our moles of hydrogen. All right, and then once we get our moles of hydrogen, we can go to moles of WO3, and then we can get our grams of WO3. But guys, there's no need to reinvent the wheel. Up here, we did 2 of these steps, all right? We started with our grams of hydrogen, we got to moles of hydrogen, so we can use that information in the next one without recalculating all of it. So if we look here, when we got to moles of hydrogen, we got 5.0 times 10 to the 5th moles of hydrogen. Let's start there. I don't feel like doing extra math. All right, that's a lie. I love extra math. But for you guys, I will restrain myself. No extra math. All right, so what I said is we got to the point where we had 5.0 times 10 to the 5th moles of hydrogen. All right, and at this point we need to get to moles of WO3. So when we do that, let's go back and look at the balanced equation they gave us, right? Isn't that nice? It's all balanced already. So for every 3 moles of hydrogen, we have 1 mole of WO3. Okay, the balanced equation gives us, we're allowed to use those coefficients in order to get this working nicely. So we'll come down here and we'll say, okay, for every 3 moles of hydrogen, we'll get 1 mole of WO3. All right, I'm just gonna show you something. I mean, calculate it out by all means, but it was the same ratio for tungsten, just so you know. All right, anyway, so let's go ahead and do the math. We'll be, extra math. It's always good. Oh, excuse me, that's moles of WO3. All right, so when we divide out, we do get 1.7 times 10 to the 5th moles of WO3. Okay, number 2. It was nice and easy. We just went to the periodic table and we're like, sweet, tungsten's right here. Let me show you tungsten. In this case, we're not just going to tungsten. We're going to WO3. So we will need to calculate that molecular mass. So in doing so, let's go ahead and we'll have W, which happens to be fresh on the brain. We have 183.8 atom. And then we have 3 oxygens, 16.00. So when we multiply that out, 183.8 plus 48, we're going to get 231.80. Remember, when we're adding, we chop at the shortest decimal point. All right, so we're just going to have 231.8 there. And remember, that's grams of WO3 per 1 mole of WO3. All right, so we've already got, coming back down here, we've already got 1.7 times 10 to the 5th moles of WO3. So what we can do is say 1.7 times 10 to the 5th moles of WO3. Make my fun little bracket. All right, I know that 1 mole of WO3 is going to be 231.8 grams of WO3. That's the mass. All right, and when we do this calculation out, we end up getting 3.9 times 10 to the 7th grams of WO3. So it's tedious, but doable. The main thing is keep in mind, and I gave you guys the cool little flip chart. Keep in mind that you can't just go from grams to grams. There's no way to do that. You'll get frozen if you try to do that. You need to go grams of hydrogen, or whatever you start with, grams of compound A to moles of compound A. Once you have a balanced equation, you can relate it to a different compound in the equation, and then, or molecule rather, and then you will take that and convert it into the grams. So that's it for this one. We'll be back in a little bit with more.